I will now rerun the analysis using mesh control. And what you'll see is that using mesh control, you'll be giving the software a smaller model to solve, yet maintaining the accuracy. So for this one, I will say still it is a high quality, but it is with mesh control. So I'm trying to control the mesh. In SolidWorks, the options of mesh control are limited. But if you have a more dedicated package like Abacus, you get much higher control on your mesh in terms of the types of element to use as well. Here we are primarily controlling the size of the element. So in this case, to apply the mesh control, I will need to again go back to my mesh tool. But instead of directly creating the mesh, I will first go on to the create mesh, apply mesh control option. I will click on this option, and on this option, I will actually click on this particular region, right, where my mesh needs to be most refined, because these edges are the ones. And then of course the face as well, because we saw that the high stress was in this area as well. So basically we will select the zones where we want our mesh to be highly refined. So basically you can see here, so I have selected edge 1, 2 and then face 1, 2 and then edge 3 and 4. So in total I have selected these 6 entities. I have selected the edges as well as the faces. Okay. Once I have done that, I will now decide on the ratio A over B. So what does this actually A over B means? It means how you want this to be transitioned. This can come with a bit of experience, but right now we will use the value which the book uses, which is 1.5, meaning that basically I think if you want to read a bit more on understanding how this A over B is affecting, you should go and read this chapter that I have already uploaded. So you can go down here and then it explains to you how the mesh control will work. Okay. Let me scroll down. So basically it's calculating the transition from a very fine mesh to a bigger mesh size. So these are all the cases, and then this is the case for okay. Right. So this is how he is again selected, like I showed you. And this is where he is explaining, right? So basically this value controls the increase of element size from one layer of element to the next as element radiates away from the selected entities, and he is giving this with the ratio. So if let's say your default element size is E, then the subsequent layer of element increase in size according to the progression E multiplied by A by B, and then E multiplied by E by A by B squared, and then so on and so forth until you reach the default size, okay, on the remainder of the model. So this is basically what we mean by the mesh control. So let's now apply that and see how that will actually affect. Now I believe, let me actually go back and confirm if he's going to move the slider back to the chorus or to the default. I think he will move it back to the default, but let me reconfirm. Yes, so he is selecting the default. Okay, so I will keep to have everything comparable. I will keep it as same, although I can easily move it to chorus if I have to. So then I will just say okay, and now you can see when I click on create mesh, it will ask me whether I want to overwrite. I'll say yes, and on this case now I will not use the fine density, rather I will basically use my mesh control. Okay, the quality is still the same. Okay, so the finest it will be based on this, and then I will just mesh the model. Oh, okay. I think I just made a small mistake here. Yes, because I didn't change it from the fine. So let's go back. So let me just recheck my mesh control. Yeah, that is okay. Okay, yeah, so I should have actually selected. I just got misled by looking at the next image actually over here, but I need to start from a chorus mesh so that when it moves back from my mesh control, it actually moves to the chorus size. So that is okay. So I've already, because the mesh control is already there, I'm not going to change it. I'll just change it when I'm going to create the mesh. So I'll start with the chorus size and then say okay. Okay, now you can see here what's happening is in the far field, the mesh has very big elements. But as you become closer and closer to the notch, you're going to that refined size. Okay, and in the very close area, you're getting the most refined element. Again, you can come to an optimal by playing with this, and you can either move from a default to the chorus. Right now, you can see that the total number of elements is 2,709, but the total number of nodes is 4,688. So this is 2,709. And sorry, yeah, and 4,688 is the total number of nodes. Let's see how much the values will change in terms of our actual results. And what we see from our running the analysis, you can see it has again taken much smaller time, much lesser time. But what you've noticed immediately from this is that your peak stress values are still actually better than your default mesh, right? They are slightly lower than the very refined mesh, but they are definitely higher than your default size mesh, and you can see the distribution is also being captured quite nicely, right? So the maximum value in this case is 173.92. So let me quickly note that down. So maximum value is 173.92. So this is still higher than the basically this mesh with 10,000 nodes. So with lesser number of nodes, we are almost getting, same results as this one, right? And by more carefully tweaking this, we can get the same results as the 80,000 model by having a much smaller model. Okay, that's what I'm trying to demonstrate. Let's look into the displacement as well. So displacement is again 4.812, which is of course not far away from this at all. So 4.812 E minus 2, and then this one remains same. This one remains. Let's check that number by going back to the stress plot and using our probe. So this time it's around 55.06. Okay. Okay, so this is minus 5.96. And these numbers are, of course, going to remain same as before. So I'll just copy them over. Right. And you can see here now the error between the hand calculated results and the FEA is around 2.6, and overall you have got a value which is actually very close to your refined results and at a much less computational cost. So that basically is what I wanted to demonstrate. So especially for, think about it from the point of view of big assemblies, you will run out of computational power. So this technique of mesh control can help you significantly in that. I will save all of this analysis. There are many other tools here to, for example, you can actually create a split line and then actually get the results on each of those nodes and then actually average them to get a more accurate value of the average rather than just me looking at each point. But I won't be doing that in the class, and you can explore the software more in your own time. I encourage you to buy this book as well, which I have been using to follow. Of course, it's not a compulsory for this course because I'm only using 2 chapters from the book. So, but for other courses, you may still find this book very useful for your practicing of finite element analysis using SolidWorks. So I've given the full reference in the slide notes. So please look at that. I think this is all for this analysis. So let me just save this recording. If anything else comes up, I'll let you know.